welcome in this video. First of all, my name is Mwiza Chirwa. I'll be taking you through chemistry. In this video, we're going to start looking at chemical bonding, one of the topics in chemistry. So let us start. By the end of this lesson or chapter, we should be able to achieve the following success criteria. Define a chemical bond, state 3 types of chemical bond, write the chemical formula of compounds, and describe how an ionic bond is formed. So when we'll be done by the end of this lesson, we should be able to define a chemical bond, state 3 types of chemical bond, as well as write the chemical formula of different compounds and describe how an ionic bond is formed. To begin with chemical bonding, it's a broad topic, but we still need to have an understanding from other topics as well. First of all, when we're looking at chemical bonding, we need to have an idea from an atom, that is structure of an atom, as well as the periodic table. So as we are going through the topics, we'll see the validity of knowing those topics, but we can still go through and learn much on this topic. So when we are talking about chemical bonding, what is chemical bonding? This one can be defined in this way. It is a force of attraction that holds atoms, ions, or molecules together in a compound. It is the force of attraction that holds atoms, ions, or molecules together in a compound. It can also be defined in another way around. We can also define it in this way. It is an attractive force between two particles. An attraction force between two particles. So, chemical bonding occurs when atoms of the same element and different elements combine during chemical reaction. If I may take you way back, in periodic table, we said some of the atoms does not exist as a single atoms. They exist as diatomic molecule, most especially we have oxygen and group 7 elements. So for them to exist as diatomic molecule, it means they join together. The joining of those atoms, that is what chemical bonding is referred to. So that's why in this statement we're saying that chemical bonding occurs when atoms of the same element or atoms of different elements combine during chemical reaction. When we're talking about chemical bonding, we're just saying joining. This joining we're referring to mutual attraction force that develop between the two atoms or more than two atoms together. So all elements starting from group number 1 and up to group number 7 in the periodic table are not stable. This one we can see through looking at the valence electrons in the outermost energy level. So for them to be stable, they are supposed to lose or gain electrons. So we can have a question, why is it different from elements? The other ones are losing for them to be stable, while the other ones are gaining for them to be stable. When we're talking about stability in an atom, they are supposed to have they're supposed to have maximum number of electrons in the outermost shell. Apart from helium, all the elements are supposed to have, apart from helium and hydrogen, all the elements must have a maximum of 8 electrons in the outermost energy level. Helium has only 1 shell, so the maximum number of electrons that are supposed to be there is supposed to be 2. Same applies to hydrogen. But helium is coming from group number 8 because it's already having maximum number of electrons in the outermost shell. So I was just giving you an example. So starting, as I said, starting from group number 1 up to group number 7, all the elements in the periodic table, they are not stable. For them to acquire stability to reach an electron configuration of group 8, they are supposed to gain or lose electrons. So the question might be, which ones are going to lose and which one are going to gain? So from the periodic table, we know that some of the elements are metals and others are non-metal elements. So for metal elements, for them to be stable, they're supposed to lose electrons. The reason behind losing the electrons it's because they have weak nuclear charge, so they cannot attract the incoming electron more strongly, to compare with non-metals, which have strong nuclear charge, so they have the capacity to attract the incoming electron more strongly than metals can do. So as element does that, they form a bond amongst themselves. So we have talked much about the stability in elements, but now we are going to shift and we're going to look at types of chemical bonding. So we have several types. To be specific, we have 3 types of chemical bonding, and these ones are as follows. We have an ionic bond, covalent bond, and metallic bond. These are the 3 types of chemical bonds that can exist between elements. So go into details about each type and how it occurs. So firstly, we're going to start looking at an ionic bond. What is an ionic bonding? So an ionic bond, it is an electrostatic force that holds ions together in an ionic compound. An electrostatic force. This is a new term that we need to go through properly, an electrostatic force. So when we are talking about an electrostatic force of attraction that holds ions together in an ionic compound, there are things that we need to align from this statement. First, we have electrostatic force, then we have an ionic compound. We need to understand them properly. So when we're talking about electrostatic force of attraction, this is a force of attraction between oppositely charged entities or particles. So when we have opposite charge, when we're talking about opposite charge, we are referring to positive and negative. So when we have positive and negative, the force of attraction that develop because they are going to attract is known as electrostatic force of attraction. An ionic compound. When we're talking about an ionic compound, we are referring to a compound that is formed when a metal and non-metal joins together. The word ionic, we are referring that ions are present in there. So an ionic compound, we have a metal and a non-metal, as well as ions are involved. Which ions? The ions with different charges. So another term must also come in, ions. So when we are referring to an ion, it's a charged atom. When an atom is charged, becomes an ion. So how is an atom charged after losing or gaining the electrons? So this type of bond, the ionic bond, occurs between metals and non-metal elements. If we look at an ionic bond, it can only occur when metal and non-metal element joins together. So how is an ionic bond formed? We need to learn how an ionic bond is formed. So firstly, in this type of bond, metals release the valence electrons. Remember, I talked about how elements get stability. So when you have a metal and a non-metal, if they are to join and form an ionic bond, this is what happens. That's why here we're saying how is an ionic bond formed. So it is a type of bond. In this type of bond, metals release its valence electrons in order to be stable and becomes cation, a cation. We're not talking about cation, we are referring to positively charged. Okay, the other question is, why do they become positively charged? It means after losing the electrons, now the number of protons and electrons, they're going to be different. Why are they going to be different? A neutral atom have equal number of electrons and protons. Now, this one has lost the electrons. If it has lost the electrons, it means now you have more positive protons inside than electrons. That's why this one becomes positively charged. So we're saying in this bond, metals release the valence electrons in order for them to be stable and become cations, positively charged atoms. While nonmetal elements accept the electrons released and by the metal to be stable. So the electrons which have been released by a metal, they don't just disappear. They are going to be accepted by a metal beside it. Why nonmetal accept the electrons? It's because it has a capacity. It has strong nuclear charge to accept the incoming electrons, the nonmetal elements. So the electrons which was released by metals are going to be accepted by nonmetal elements, and if it accepts the electrons, the nonmetal, it becomes an ion, a negatively charged entity or particle. Why is it negatively charged? Because now number of electrons, they are more than the number of protons. Therefore, the charge of that particular atom become negatively charged. So we can see the metal releases the valence electrons, and those valence electrons released are gained or accepted by nonmetal elements. And if a metal loses the electrons, it becomes positively charged, while a nonmetal, after gaining those electrons, becomes a negatively charged. So this is where the electrostatic force of attraction now becomes. So the oppositely charged ions attract to each other and form a bond. Remember, we said opposite charge get attract, while same charge do not attract, but it repels. So the opposite charge which have been developed attract to each other and form a bond. It is called an ionic bond because ions are formed in the bond. How ions are formed? We have already explained that ions are going to be formed when a metal has released the valence electrons, as well as when a nonmetal gains those electrons. This is how a metallic, an ionic bond is formed. Example. Now we're going to start looking at specific examples that can specify as well as explain more how an ionic bond, or example of how an ionic bond is formed, and which examples are there. So when an ionic bond is formed, it created an ionic compound. So that compound, we can explain how it was formed, or it is being formed. So the first example that we're going to look at is how sodium chloride is formed. Sodium chloride is an example of an ionic compound because we have a metal, which is sodium, and a nonmetal, which is chlorine. So in sodium chloride, there are two elements. We have sodium and chlorine. Sodium is a metal, hence it releases its valence electrons and become positively charged cation. Chlorine is a nonmetal which gains the valence electrons released by sodium and become negatively charged ion. The opposite charged ions attract each other and form an ionic bond. Note, usually one or two or three valence electrons can be released by metals depending on the number of valence electrons they have. What does this statement mean? We're saying that since we have different metals, we have group 1 elements, which in the outermost shell they have one valence electron. We have group 2 elements in which their outermost shell they have 2 valence electrons. We have group 3 elements. For example, aluminium has 3 valence electrons. So for these metals, for them to be stable, has to release all the valence electrons. Hence, that's why there is this statement which is trying to tell you that it is not only going to be sodium who is going to be involved in an ionic bond. There can be metals from group 2, there can be metals in group 3 as well. So for them to be stable, they have to release their valence electrons. And these valence electrons are going to be gained by nonmetal elements. We are going to go further much on this when we look at how compounds are formed. I'm going also to come back and explain much on this. So we have a diagram showing how sodium chloride is formed. As well as nonmetal elements can also gain 1, 2, or 3 electrons depending on the need for them to be stable. Same applies to non-metal elements. They can release 1, 2, 3 depending on the number of valence electrons they have in the outermost shell. While for non-metal elements, they can gain either 1, 2, or 3 depending on the need for them to be stable. When we're saying the need, we're referring to reach electron configuration of noble gases. So we have sodium here, which has 1 valence electron, as you can see, which is represented by a dot. Then we have chlorine here, which has 7 valence electrons. So if you check, if this one releases 1, becomes stable, and this one needs to gain 1 electron for it to be stable. So the arrow showing that sodium is releasing the valence electrons, which is going to be gained by a chlorine atom. After this one happens, you see sodium becomes positively charged while chlorine becomes negatively charged. So it is these charges which get attracted and form an ionic bond. Example 2, we can also use an element from group 2. We have magnesium and chlorine. So in magnesium and chlorine combine, they form magnesium chloride, as you can see the chemical formula. In magnesium chloride, there are 2 elements as well. We have sodium and we have sorry for typing error here. We have magnesium and chlorine. Magnesium is a metal and it has 2 valence electrons. Hence, it releases its valence electrons and become positively charged cation. Now the charge changes. In sodium, we had 1 and here we have 2. These 2, positive 2, it is saying that the atom now, after releasing valence electrons, it has more than 2 protons to compare with the number of electrons. That's why here we have positive 2. Chlorine is a nonmetal and has 7 valence electrons. For chlorine to be stable, it needs to gain a single electron. Therefore, in this bond, there are going to be 2 chlorine atoms in order to balance up the number of electrons which are going to be gained. That's why in the previous slide we said the chemical formula is MgCl2, showing us that we are going to have 2 chlorine atoms. Each of them is going to gain a single electron for it to be stable. And chlorine has a -1 charge. This is telling you that now it has 1 more electron than proton. The opposite charge ions attract each other and form an ionic bond. The diagram is this. We have 2 chlorine atoms. The valence electrons are going to be released by 1 magnesium atom, and each chlorine is going to gain 1 electron, which is one electron from magnesium. After it has been released, this one becomes positively charged. As you can see here, we have positive charge. This positive charge is for magnesium, and chlorine becomes negatively charged. As you can see inside here, we have negative charge, negative charge. So these are oppositely charged. Here we have positive, here we have negative, get attracted and form a bond. Example 3, explain how calcium oxide is formed. In calcium oxide, we have two elements as well. We have calcium and oxygen. Calcium is a metal, and that has two valence electrons, hence it releases its valence electrons and become positively charged. And oxygen is a nonmetal. For it to be stable needs two electrons, hence it gains the two valence electrons released by calcium and become negatively charged. The oppositely charged ions attract each other and form an ionic bond. This process is illustrated by the diagram in the next slide. As you can see, we have calcium, we have oxygen. For calcium to be stable, it's supposed to release the two valence electrons which are found in the outermost shell, while in oxygen, we see that oxygen has 6 electrons in the outermost shell. So this shell, for it to be maximally filled, is supposed to have 8 electrons. So this oxygen gains the 2 electrons which have been released by calcium and to become stable. After it gains, it develops a negative 2 charge, while this one, after releasing it, develop a positive 2 charge. So the opposite charges which are here get attracted and form an ionic bond. I'm writing now the chemical formula of compounds using the valences. When writing chemical formula of different compounds, we use valences of elements involved. So what is a valence? It can be defined in two ways. It is defined as number of bonds an atom can make, or refers to combined power of an element. These are the two definitions that we can use when we are defining valence. You can check this valence and another valence where we have E here instead of Y is different. The other one is referring to the number of electrons in the outermost energy level, while this valence refers to as the number of bonds an atom can make or combined power of an element. So this one helps us to write correct chemical formulas. The valence of an element can be determined by number of electrons in the outermost energy level. This statement has a backup here. The group in which the element belongs is the same as the number of electrons in the outermost energy level, which is the same as the valence. This information only applies from group number 1 up to group number 4. It only, I repeat, it only applies only from elements from group number 1 up to group number 4. It does not work for elements starting from group number 5 up to group number 8. So how do we find valences for elements in group number 5 to group number 8? In the previous slide, we've said that for us to know the valence of elements from group number 1 and up to group number 4, we just look at the number of valence electrons. For example, if we go to group number 1, we'll see that their valence electron is 1. It means their valence is 1. If we go, for example, aluminium is found in group number 3 and it has 3 electrons in the outermost shell, it means its valence is 3. While in group number 5, for us to find the valence, we usually count the remaining number of electrons for each element to reach an electron configuration of noble gases. For example, in group number 5, we have nitrogen. Nitrogen has 5 electrons in the outermost shell. So in that shell, the maximum number of electrons for it to be to reach electron configuration or stable is supposed to be 8. So we subtract 8, we subtract 5 from 8, and the answer will be 3. That's why you are saying that therefore the valence of group 5, 6, 7, and 8 are 3, 2, 1, as well as 0, respectively. Note some elements have more than one valences. These include copper, which has 1 and 2, iron, which has 2 and 3, as well as lead, which has 2 and 4. Usually these ones are elements from the big periodic table that are coming from transition metals. Steps followed when we are writing chemical formula of a compound. The first step is to write a correct chemical symbol of an element or radical. For example, we have a chemical symbol of potassium, which is K, chlorine, which is Cl. We write them correctly. Write the valences of elements above to the right hand side of each symbol. So we write the valences on top on the right hand side of each symbol. Then we are going to exchange their valences by swapping. That's why here we have an arrow showing you that this one comes here as a subscript and this one here comes here as a subscript. From there, we write the combined chemical symbols to form a compound. For example, write the chemical formula of calcium fluoride. Calcium is coming from group number 2, its valence is 2. While fluorine is coming from group number 7, it has 7 electrons in the outermost shell, so the remaining one is 1, that's why here we're having 1. When we swap, the 2 goes to fluorine as a subscript and the 1 comes to calcium. That's why this one is the chemical formula for calcium fluoride. We also have an example of, we can also write iron 3 oxide. We're saying iron 3 oxide. These 3 in the brackets, it's telling you that the valence of iron is 3. That's why here we have 3. So oxygen is coming from group number 6. Its valence is 2. Then we swap. This is the chemical formula of iron 3 oxide. We can also write the chemical formula of water. Water, we have 2 elements. We have hydrogen and oxygen. Hydrogen, the valence is 1. It's found in group number 1. While oxygen, the valence is 2. It's found in group number 6. It means it has 6 electrons. The remaining one is 2. That's why I have 2 here. When we swap, we're going to have H2O. This is the chemical formula of water. And another example, it can be for carbon dioxide, which is different from the other one. The valence of carbon is 4, while oxygen is 2. But amongst these ones, we have a common factor, which is 2. We can simply divide 2 here, and 4, we're going to have 2 here, and the 2 and 2, we're going to have 1. That's why we have CO2, telling us the chemical formula of carbon dioxide to be CO2, not C2O4, because we have a common factor amongst the valences. So in this slide, we are going to look at a passation. The meaning of passation simply means a quick exercise from what we have covered. So the first question is about a metallic element X has a valence of 3 and another non-metallic element Y has a valence of 1. Write the chemical formula of the compound they form when they combine. Question number 2, an element P with an atomic number 3 combined with element Q whose electron configuration is 2,6. Write the formula of the compound they form when they react. We have another one. Nitrogen atom has a valence of 3, whereas hydrogen atom has a valence of 1. Ammonia gas is formed when the 2 combine. Write the chemical formula. Then the other one, write the chemical formula of copper to sulfate. Given the valence of the radical, sulfate is 2. Write the chemical formula of aluminium oxide. So these ones can be attempted. Then we also have another one, using a dot, continuation of the passation, using a dot and cross diagram, describe how the following compounds are formed: magnesium oxide, lithium oxide, calcium bromide. Given the following structure, explain how it is formed. So from the structure, everything is illustrated. You can just explain how this one is formed. Usually it's a potassium chloride. How is it formed? So for any questions, you can contact us on this WhatsApp number. You can visit Xulendo using this link to find more. So these are the resources that you can consult when maybe you need to learn more about whatever we have been discussing. You can use Excel and Success Junior Chemistry Book 2, Achievers in Chemistry Book 2, Django Chemistry Book 2, Target, as well as maybe if you need more about the photos, the images that we have used, we also have some links here. You can learn more from that. That's the end of this video and the end of the presentation on the first lesson on chemical bonding.